point of view, I like greenhouse, I like outdoor, but I don't know if that's necessarily the same. We get a very, very high quality out of that type of biomass input, and because that biomass is way cheaper than how we do it indoors, we're going to see a lot of solvent extraction come out of greenhouses and outdoor crops. That is how it's shifted over.
And generally a higher percentage of crop contamination in the more outdoor. The more you can control your environment, the more you can minimize the incursion of various pest pathogens.
So for solvent, that works for us, right? Because we're purifying it.
Because we can wash it out,
we can wash it
filter
out,
into a level that removes all those.
Yeah, exactly. But for solvent,
you're limited to only being able to cherry the lots of flower that's harvested, or when you have really good years and you have really immaculate looking material, because a few of the insects you can filter out based on the size of the insects, but the minute you start looking at microbial contamination, those microbes are small enough that they can actually sit spores on the surface of the glandular trichome. It's very difficult to sterilize those hashes if they're contaminated with some of the more dangerous molds and mildews. Now, I'm probiotic. I love organic products, but one of the things about legalization, as we start transitioning into regular market, we have to test those products. And when we're sourcing material, we actually differentiate and say, hey, there's a certain amount of beneficial bacteria that we're going to allow in our process. But if it's any bacteria that's producing things like mycotoxins, we can't allow that because it's going to get concentrated in the solventless process. In the solvent side, we can take that material and it won't be as good as maybe those live resins, because we'll have to send it through various types of filter medias to remove those spores, filter it down to a really small micron to make sure those spores don't get through. But we can actually take that percentage of the crop that is slightly contaminated and still be able to produce it into a relatively good quality, high terpene content, and then sell the product.
So how about for us, our problem with extraction is pesticides has been a problem. How does that shake out?
It works. Sometimes it depends on the pesticide, but it'll transfer through. What I really wanted to say with what you guys were speaking about was that for me, I let my processes do the talking. So we're not just a process and we are the unveilers of the flame, but the other thing we do is we can let people know this cultivar is not ideal for this process, but it probably will work well in this process or this process. So when I get material, whether it's greenhouse, whether it's field, whether it's indoor, I'm going to run it through a variety of processes. I'm going to check out how it sifts, how it washes, the rosin from the bubble and the sift and the flour, and that creates a sort of landscape for me to have a better understanding of, and then you get to share that information. So we can really work in a symbiotic way with farmers if they're growing for extraction. How to know like what varieties you want to grow because of literally the live resins that you make, or the CO2 oil that you extract, or the water hash or dry sit. So,
and I think that catalog is slowly revealing itself.
Absolutely.
Which cultivars have come to the top and like the best terpenes and the best yields.
But those are trends and they change.
They change, yes.
Yeah, which is hard for us because when we find something that actually has that profile, that trend that people are on right now, whether it's gassy or funky or fruity or whatever, hazy, it's hard to find those cultivars that are still going to give you, enough yields, not take too long to still give you some margin that you can make some money with your grow. And then everyone just changes and we're on to this now. We want the fruity pebbles or whatever.
Well, and I think that leads credence to no matter what happens, some of the worst political decisions I've seen down in the U.S. was when states prohibit medical patients or home growers from being able to cultivate plants themselves and process at their own home. Because I'm able to go down to those states that have home growers, allow home growers, and they can cultivate phenotypes that I don't have access to in the market, test wash those products on a very micro scale, and give us the feedback on those genetics on whether or not they do good on this solvent or this solvent, whether or not they're washers or we got a solvent blast them. And that opens up essentially us as commercial operators of relatively expensive facilities. It's very expensive for us to do we're not purchasing kilos, we're purchasing hundreds of kilos that we're then processing into tens of kilos of product in order to supply the provincial or international markets. So it's very expensive for us to take a test, a risk on 100 kilos. And there have been a few states that ban home growers, home processing. And when I lived in those states that banned home grower, home processing, I left. Because there's other markets, and those markets are going to open up, and there's going to be better products, better research, and better horizons for us as commercial companies.
Well, what is the ideal size for that batch for you guys to get a good test? Do you have enough product?
It depends on the equipment that I'm running it through. If it's flour rosin, I don't need much at all. If I'm running it into water hash, I can do small washes. I could do 5 gallons or whatever, but our small wash is about 6 dried kilos or 35 fresh frozen kilos. With dry sift, it's around, I think it was 3 kilos that we throw into the unit. So it really depends on the equipment.
3-4 per batch, but then you always go for run a couple of batches, right? Because you might have some variation. But if you know your machine can fit 5 kilos, I'm gonna run 4 batches. That's 20 kilo test batch. Then I can go through and say, hey, here's what we did with slightly different parameters over 4 different runs. Here's how we can actually take those numbers. Here's what's performing well, what's not, and then we can actually start scaling those 20 kilo test runs up to the production level scales. So that's really hard to do on a commercial level, but being able to work with home growers and being able to have that free trade of knowledge between home growers, home processors, as well as licensed commercial operators really opens up the market. And I think the same thing's going to happen. There are very few nursery licenses operational here in Canada. Those are going to come to market, and as those come to market, we and the home growers are going to be able to say, hey, these strains work really well for these specific processes. So if you're a home grower and you don't want to buy a hydrocarbon rig, maybe you just want to do an alcohol wash or make a tincture or make a topical with it, these are the strains that we think work well. These are the ones that have these cannabinoid or terpene profiles, and these are the ones that can then be processed into these specific end products based on essentially our experience, our idea on the private home scale, as well as we scale that up to the commercial operating businesses. Because there are strains that I think are lovely to wash on a home scale, but we can't make them commercial.
So many of them. Yeah, so many.
So,
any questions?
We could talk about what's coming in the world of extraction, which is on the field, liquid nitrogen, mass acreage extraction, extracting trichomes into 55-gallon barrel drums, and changing the way we extract when suddenly we can put resin glands into our machines instead of plant biomass. And so that will change the way we extract live resin. It will change the way we extract water hash. With water hash, it's now extracted. All you need to do is really run it through the water, allow it to fall through the screens, pull out whatever contaminant there is, and then there's also people working on the static sifting machine that will charge statically. You pour those heads in, they'll take everything out, and then probably eventually break them down by micron or full spectrum profile, whatever you want.